P8 revision. We're going to look at the 4 areas of forces in balance. So apologies here, this is where resources are a bit inadequate, but forces in balance is P8. So this is the module we've studied, and we want to break it into 4 areas and look at each one in a bit more detail. So we're looking at vectors and scalars. Then we're looking at the forces between objects, resultant forces, and then the centre of mass. Okay? So, vectors and scalars, what are they? Start with scalars first. Scalars have a size. So a good example is speed. So scalars, speed, easy way to remember it. It has size, but no direction. So 100 meters per second, for instance. Whereas a vector has size, but it also has direction. So that's the difference between them. And a good example of a vector is velocity. So vector velocity, scalar speed. Easy to remember. 100 meters per second north. Okay? Other examples of vectors are acceleration, displacement, force, momentum, drag. So you would typically see these on a diagram like this with arrows to show the direction of each. Whereas these are scalars and they don't have a direction. Temperature, distance, area, volume. Okay? You'll be expected to be able to give examples of both and say what the difference is between them. Vectors have direction, scalars only have size. Okay, moving on. Let's look at forces between objects. So forces are measured in newtons, which is capital N, and forces can change the speed and the shape and the direction of an object. We have 2 different types, contact and non-contact. So contact forces have to physically interact, they have to physically touch to exert their force, pushes, pulls, air resistance, drag, water resistance, friction, physically touching. Non-contact forces are gravity, which is pulling everything down to the centre of the earth, electrostatic attraction, and magnetism. So you will be expected to give examples and know the difference between them. These don't have to touch the object to exert a force on them. And this is Newton's 3rd law. When objects interact, they exert equal and opposite forces on each other. So if you can imagine an object sat on a table, put a ball on the table, there is a force pulling down. In this case it's gravity, which is a non-contact force. But we also have a reaction force from the table, which is pushing the object back up. If that force wasn't there, the ball would sink through the table. So we have 2 forces which are exerting on each other, and they're equal and they're opposite. So that's his 3rd law, and that's what it means in reality. Okay? Okay, moving on. Resultant forces. Resultant forces are the overall forces which are acting on an object. So we take the bike here, we have a forward force, a thrust of 50 newtons. We have air resistance of 20 newtons. The overall force is going to be 30 newtons, which is the difference between those 2 numbers in the direction of the biggest force. Okay? So resultant forces, when you only have 2, they're quite easy. Now let's look at this example here. A flying object, usually they give you a jet or something like that, an aeroplane. But kite is easier for me to draw. So 4 forces acting on this one. 5 newtons up, 8 newtons to the left, 12 newtons to the right, 3 newtons down. Let's simplify that by subtracting the forces which are opposite each other. So 3 and 5, we have 2 newtons up and the biggest force here, 12, take away 8, is 4 newtons to the right. So we have 2 overall forces acting, but we want to know the one overall force for this particular object. So the way we do that, we can draw this out to scale. So 4 to the right, 2 up. We have drawn out the rectangle here, and the resultant force is this red arrow here. So that gives us size and direction. To calculate the size of the force, we use Pythagoras. So referring back to your maths here, if we use a squared equals b squared plus c squared, then 4 plus 16 is 20, square root of 20 is 4.47. So the resultant force is 4.47 newtons in that direction. Centre of mass. You've got 2 examples here, symmetrical shapes and irregular shapes. Now, what is the centre of mass? It's this. It's the point on an object where the mass of the object is thought to be concentrated. Okay, so on symmetrical shapes it's quite easy. It's the intersection of the lines of symmetry. Okay, so nice easy one. It doesn't matter what the shape is, as long as it's symmetrical you can work it out. Irregular objects, you have to suspend them and then have a plumb line which you draw a line along. So you draw a line along here on the object. Then you would suspend it again, and I've already drawn the lines in. So say we suspend it from this point here, and it turns around, plumb line down, we draw the same line, and it's where those points intersect. Okay? So you have to do an experiment here to find the centre of mass of an irregular shape, whereas symmetrical ones you can work it out just by drawing the lines of symmetry and finding where they intersect.